by this 802.11. One is the basic service set, another is the extended service set. So these two services provided by this standard. So basic service set means that is a BSS. Basic service set means it is a BSS, and this is one of the basic building block of any wireless LAN. You can call in this little that is a BSS. That is one of the basic unit of a wireless LAN, and it has some characteristics how you can communicate within a BSS, how you can communicate from one BSS to another BSS. So let us see what do you mean by BSS. So basic service set means you can see here there is some workstation is there. So this is workstation 1, 2, 3, 4 here. There is another in this figure. There is some workstation. Inside this there is a access point. So this access point is optional. So inside this, whether these workstation are stationary or mobile in the nature, mobility in the nature. Either you can put the fixed uh, node, or the node may be the mobile node. That means you can move from one place to another place. So this is the you can take this type of node to form a PSS. Now you can see this is one BSS, this is one workstation, this is another workstation, this is another workstation. These four workstations can communicate each other without using any infrastructure, without using any infrastructure. Without using infrastructure, you can communicate to each other. If this is the situation, that means taking 4 to 5 workstations, either the workstations are mobility in the nature, or they are the stationary, means they are fixed position. And taking this node, you can communicate to each other without taking any infrastructure support. Without taking any infrastructure support, then this is called a BSS without access point. So suppose you take 4 to 5 mobile nodes, they can on their Bluetooth and they can communicate to each other. That means they don't require any infrastructure. They don't require any physical infrastructure for their communication. Then that type of communication is known as a BSS without access point. A BSS without access point. And this type of wireless LAN, this type of wireless LAN is known as the ad hoc network. So ad hoc network is one type of wireless LAN where you don't require any infrastructure. It is an infrastructure less wireless LAN. It is an infrastructure less wireless LAN. Neither this node is connected to any other device or any access point or any server. It is totally independent. And this workstation can communicate to this workstation, this workstation, this workstation. So among them, they can temporarily they can form a network without taking any help of the infrastructure. Then this type of network is known as ad hoc network. This type of network is known as a ad hoc network. Then you can see this structure. This is also BSS, but here one infrastructure is there. One infrastructure, that means here one access point. That means one BSS to one workstation to other workstation in the same BSS you can communicate to this access point. So this access point. So that means suppose you can see in our silicon corridor, you can see in some places you can find there is some access point is there. There is some access point. Using that access point, you can access the internet. You can go for chatting with each other. So that is called a wireless LAN, but it is you require some infrastructure. That is also wireless LAN. That is also wireless LAN, but you need some infrastructure for communication. You need some infrastructure for communication, and that is known as BSS with an access point. Now this is the BSS. Now you can take the within BSS, one BSS to other BSS, if you want to communicate, you require a access point. You require a access point. We come to that point. That is called your extended service set. So a BSS without access point is total standalone network. A standalone network. Then it is called your ad hoc network or infrastructure less network. A BSS with access point, then it is called, it is an wireless LAN, but it is a infrastructure based wireless LAN. That means your Wi-Fi it is a wireless LAN, but it is based on the infrastructure. If you remove the access point, you cannot communicate. So that is a ad hoc network. But if you require some infrastructure for your communication, then it is a wireless local area network with infrastructure. With infrastructure, your Wi-Fi is the example of wireless infrastructure based network. And now we'll go for the extended services. That means your ESS. Yes, what is ESS? That means what I discussed within the same BSS, you can communicate. Whether without access point or with access point, you can communicate in a single BSS. From one BSS to other BSS, you can communicate. Then that type of service also provided by the IEEE 802.11. Then that is known as extended service set. You can see here, this is one BSS. This is one BSS. This is another BSS. This is another BSS. Three BSS, and all these BSS having a access point. This BSS one having a access point. This BSS access point. This BSS access point. Suppose one of the workstation of BSS one want to communicate one of the workstation of BSS. So what they have to do? They have to connect it with a distributed system. They have to connect it with a distributed system. And this distributed system is connected to a server or gateway. Distributed means you can see your maybe all the access point is connected to a router, all the access point connected to a switch, where your information and this switch is connected to a server or the gateway. So whenever BSS one of the workstation or one of the node of BSS one want to communicate with BSS 3, one of the node of BSS 3, and what they will do, so this node will first communicate to this access point, then this access point will communicate to this distributed system. It may be switch, maybe other type of other system, and from this switch it will distribute to the access point, the BSS 3 of the access point. From this access point it can communicate to the node. So this is the way your extended service set is supported by your IEEE 802.11. So these are some basic difference. You may get the short question, what the difference between BSS and ESS, that you can say. What is the infrastructure less network, infrastructure wireless LAN with infrastructure less, wireless LAN with infrastructure base. Give some examples. So this type of question you may ask in the end-term exam. Short question. And next we'll see what are the different uh, workstation, or what are the different types of workstation supported by this standard. So there are three types of workstation defined by their standard based on their mobility. So first, no transition. No transition. That means it's either stationary or moving only inside a BSS. Only inside the BSS you can communicate. So that means this is a no transition. There is no transition. That means you cannot communicate outside the BSS. This is a BSS transition. That means you can move one BSS to another BSS, but the movement is consistent. It is defined inside a one ESS. That means this is called a BSS transition. One BSS to another BSS. And all these BSS are defined in a single ESS. Single ESS. You can see here, this is one ESS. One BSS to another BSS. You can communicate through the distributed system, and distributed system connected to the server. So this is called your BSS transition. This is called BSS transition, means one BSS to can communicate to the other BSS. This is called BSS transition. Inside the same BSS only you can communicate, that is no transition. That means outside you cannot communicate the other BSS. Then another, the ESS transition, means one ESS to another ESS you can also communicate. That is also possible, but there is no guarantee for the continuity of the communication in that case. One ESS to another ESS you can also communicate. That is called ESS transition. That is called ESS transition. So no transition means you can only move inside a single BSS, so there is no transition. That means you cannot communicate to the other BSS. And from one BSS to other BSS, you can communicate. That is called BSS transition. From one ESS to another ESS, you can communicate. That is called ESS transition. So these are the workstation defined by the IEEE 802.11. So these are the station defined by the IEEE 802.11. Now there is other things also is there, because your physical layer, remember your physical layer define the medium. Your physical layer define the medium for the communication, whether you wire medium, wireless medium, it will handle by the physical layer. So to handle by the physical layer, there is some rule by IEEE 802.1 how the physical layer will decide the medium for the communication between or among different wireless devices. So for this, they have to implement some of the function, some of the mechanism or technique. What is the DCF? We will discuss later on. Distributed coordinate function, which is there in the physical layer, which is used to decide whether that particular wireless device can communicate to that particular medium or not. Another is the PCS, another is point coordinate system. This also used in your wireless communication and by the physical layer to decide whether the wireless device can communicate or can share the medium or not. So these are the things we'll discuss later on. PCF, DCF we'll discuss later on. Another concept here, already have discussed CSM-CD protocol. CSM-CD protocol is used to detect the collision. That is the use of this protocol. So can you this protocol is implemented in the wireless medium or not? That's the question. CSM-CD protocol can you implement in wireless medium or not? That's the question mark. Because specific CSM-CD is designed, that is your design for your wired LAN to detect the collision. If the collision is occur, it will be detected by this protocol. Can you apply this protocol, CSM-CD protocol, in wireless medium for detection of collision? So the answer is no. You cannot implement this protocol in wireless medium for the detection of the collision. Why you cannot implement? So there is some, you can see the answer. Why you cannot use the CSM-CD protocol in the wireless LAN, and why you will move for the CSM-CA. See, CSM-CA generally used for wireless communication. CSM-CA already discussed. CSM-CA used for wireless communication. Because of this, why you will go for the CSM-CD protocol? Because CSM-CD you cannot implement in the wireless medium because of these three reasons. The first reason is because wireless device, because if the collision is occur, wireless device cannot send the data as well as the collision signal at the same time. It requires the more bandwidth. It will increase the bandwidth. It will increase the bandwidth. And practically it is not possible. Practically it's not possible uh, to apply this CSMC protocol in that scenario. Because you can say the wireless devices are very small, they have limited bandwidth. They have limited bandwidth, and if the collision is occur, they cannot transmit the data as well as the collision signal at the same time. And if you can do it, but it requires huge amount of bandwidth, and which is practically not possible. That is one reason. The second reason is collision may not be detected due to the hidden terminal problem. If you implement this protocol in wireless medium, collision is maybe occur, but this protocol cannot detect this collision because of the hidden terminal problem. We will go to that part later on, discuss what do you mean by hidden terminal problem. This is second reason. Third reason is if the signal is moving for a long distance, if signal is moving from the long distance, after some time signal may be weak. And because of that, the terminal which is far away from the sender, it may not be hear the collision. And during this situation, it is very difficult to detect the collision if the collision is occurred, and this is known as exposed terminal problem. So these are the two important challenge or issue which is associated with this protocol, and that's why this protocol is not implemented in wireless medium. It is only implemented in the wired LAN, your physical LAN. And for this, your IEEE 802.3, there is a guideline how this is used, the wired LAN to detect the collision. Now you see what is what is the hidden terminal problem and what is the exposed terminal problem. These are two concepts we discussed in the class. And let us see hidden and exposed terminal problem. Now I have three wireless device A, B, C. Wireless device means they have a limited communication range. They have a limited see, I have a Bluetooth. Bluetooth means there are some communication range. You cannot transmit the data using Bluetooth of 100 meter or 50 meter. There is some communication range for each wireless device. So we have three wireless device, one the A, B, C, and each wireless device has its own communication range. Now you can see here A want to send data to the B, and C also want to send data B at the same time. Is it possible or not? There are three wireless device. A want to communicate or want to send a message to B. At the same time, C also want to send a message to B. Is it possible or not?
Yes, sir.
No, sir, that will be
Is it possible?
no, sir.
Why it is not possible?
So there will be collision.
How it is collision? How there is a collision? Now I can see here. A send to B, A send to B. Whenever A sends some data to B, and C cannot hear because she is far away from the, C cannot hear. And but whenever C want to send the data B, A cannot hear. So that's why A thinks the medium is free. C also think medium. Even A is communicating to B during that time. If C sends the medium, medium is free because C is away from the A. C is away from the A. And both of them they sense the medium, medium is free, and the same time they transfer data, there is a collision or not. Because A is hidden for C. A is hidden. That is the third point. A is hidden for C. I think whatever the communication is done from A to B, it is not transmitted to C. So C thought that B is free. Device B is free, and the same time C will communicate to B. And there is a chance of collision at the node B. That's why your the CSNCD protocol, even there is a collision, it cannot detect. It cannot detect because this C is away from the A, and C cannot hear whatever the communication done by A to B. So CSNCD cannot detect it during this time. And when C sends the medium, medium is free. So sensing the medium is failure because A and C are hidden to each other. A and C are hidden to each other. Now, what is the solution? How to handle this scenario so that they don't have any collision? They can communicate. What is the solution to the hidden terminal problem? Is there any solution?
यस सर सर हम अगर मतलब ए का ट्रांसमिशन रेंज अगर बढ़ा देंगे मतलब बहुत मतलब सी तक चला जाएगा तो
कैसे बढ़ा देगा तुम? ये तो डिवाइस है ना, कैसे बढ़ा दूंगा? चेंज द हार्डवेयर, जैसे करने जो हो जाए, कितना डिवाइस होगा, सबका हार्डवेयर चेंज कर दूँ तो इसे practically it is not possible. Maybe you take one or two device, you can change it. Practically, if you take a large number of wireless devices there, it is not possible. But there is some other way you can avoid the collision. So what is that? You can say you will see. Now you go to the solution. After that, you will go to the. So there is a concept of RTS and CTS mechanism is used to avoid the collision or detect the collision. Remember, RTS and request to send, clear to send. These two mechanism is used in wireless medium to detect the collision during the transmission, or to check the medium during the transmission whether medium is free or busy. What is the exact concept? You can see here three node already told. This is the scenario. A, B, C. A and C are heading to each other. A and C are heading to each other. And both A and C can, if you communicate same time, there is collision at B. Now you can see here. So the rule is, suppose A want to communicate to B. So the first rule is A has to issue a RTS message to B. He has to issue a RTS message to the B. That is the first rule. In wireless medium, any node want to transmit any data to any other device, wireless device. First, it will automatically issue a RTS message to the corresponding destination. And you can see RTS message is transmitted. This RTS message moved to the B, not to the C. This RTS message moved to B, not to the C. Here, first RTS. The second step is, suppose B received the RTS. B received the RTS. Now B is ready to access the data from A. So what B will do? B will issue a reply package that is called CTS. That means I am agree to receive your data. So this CTS will move both A and C, because B is common to A and C. B is common to A and C. So whatever the communication done by B, both A and C are received. So B will issue a CTS, and that CTS will move to A as well as move to C. So what C will think, because C have never sent any RTS, still C is getting the CTS. This indicates the medium B is busy with other node for the communication and medium is not free. So C has to wait till the medium is free for the communication. So this is the process to avoid the collision in hidden terminal scenario. So first A issue the RTS, and this RTS move to the B, not to the C, because A and C are hearing to each other. They cannot hear the communication of C, cannot hear the communication of A. Now what B is doing? B is issuing the CTS. B issued the CTS. This CTS will be this type. B issue the CTS. And when B issue the CTS, this transmit the CTS, this CTS is moved to A as well as C. So this indicates the to node C, because I have never sent any RTS, still I am getting the CTS. This indicates the medium is busy. That means medium is busy, it is not free. So C has to wait until the transmission is complete. Now once the A got the CTS, the A transmitted the this thing. A transmitted the this. A transmit the data. So once the data received by the B, B transmit the acknowledgement. And this acknowledgement move to A as well as C. Move to A as well as C. And once the acknowledgement is stopped, this indicates the B is free and medium is free. Now you can see can communicate to B. So this is the way your hidden terminal problem is handled using this concept. Clear? Is it clear this concept?